This is Mark Gerard from Siemens speaking. We have an exciting event planned for you today. So we're going to be talking about latest technology, basically in the food and beverage industry, not only from a manufacturer's perspective, but also from a delivery perspective with our partner Grantek. So basically, the content of this is really developed from feedback from our customers. So we're hearing about large global demand in food and beverage globally. This is both a challenge and an opportunity for Canadian manufacturers. And in years to come, there's going to be an exponential demand in food globally. So if Canadian manufacturers can take advantage of this trend, it's a tremendous opportunity. But it also presents some challenges as well. So we're going to talk about how to potentially overcome those challenges. And by talking to you about our digitalization solutions, specifically for food and beverage. We can help you develop this roadmap from your current state to your desired future state. So understanding the concepts is kind of the first step. Second step is we can help you start to put together that roadmap to help get you to where you want to go in the future. So that's what we're going to be talking about today. We have two keynote speakers lined up, Shalabh from Siemens and Sam from Grantek. So we have a lot of experience dealing with both digitalization solutions from a technology standpoint and also implementing those solutions so that we're not just talking about technology, we can support it locally, we can install it locally and make sure you're taken care of long-term. So that's what we're all about today. What we're going to do is for questions, if anybody has questions throughout the next 45 minutes, I'd ask that you please enter them in the chat window. And at the end of the 45 minutes, we're going to address any questions that you have at that time. Okay, so I'll hand it over to Shalabh, and you can tell us all about digitalization in food and beverage.
Thank you, Mark, and welcome everyone online for the digitalization approach of Siemens, along with our partner Grantek. Sam and myself will be basically taking you through basically a technological landscape that Siemens drives in food and beverage industry on digitalization. We'll share our experiences around the technology as well as use cases and how we can go about implementing this, right? So a little bit to give you a idea of how the session would be, we'll talk about the food and beverage industry trends, and we'll talk about the technological solutions on digital twins, as well as IoT and closed loop manufacturing. We'll conclude the session by also talking about road mapping and where do we go from here when you have the overview. So let me start by talking about complexity. And really, you would say, why complexity? Digitalization is supposed to be making things simpler for us, right? And it's a kind of oxymoronic in that sense, but with data and IoT being central to the digitalization approaches, you have so much information inflow and outflow that suddenly everything needs to be taken into consideration. There are expectations from our customers, and there are expectations from their own customers. So I actually always think that when you're looking at this disruption, you actually have to look into complexity, and you have to look at what our customers as manufacturers are asking for and what their customers are also asking for, and then roll it back into a disruptive model in which every organization will actually go through this digital transformation as we speak. Some of them are already going through it. They're at a different degree of maturity, and some of us are looking to maybe even start. So I'll try to make it a mix of for everyone, but of course there would be certain specific areas which we would not be able to cover in a 45-minute session, but we'll be happy to discuss that later. So this explosion of complexity is something which digitalization is actually embracing and also in a way driving, because we need to make things simpler. So what our customers are asking, and their customers really are asking for them to deliver on things like individual products, right? Uh, Basically, when I say individual products, it also means customized products. They're asking for like really quick deliveries and high quality products which are healthy, where they can even trace the origins of the ingredients. All of these are demands of our customers. So in the food and beverage industry, if you look at the consumer space, these are the typical requirements which are being asked by their customers. So how do you use this complexity really to a competitive advantage? And as a manufacturer in this industry, how do you embrace this and you take these demands from your customers and try to deliver on them? So let me give you a few examples. When you're looking at faster delivery, you need to look at whether systems can make their own decisions, right? Because so that there is no delay in your supply chain process, in your manufacturing process, that there's a delay because of human impact. So can these systems make their own decision? That's what you need to look into. When I talk about individual or customized products, do you as a manufacturer have the ability to produce flexibly anywhere and anytime? Is that the model which would be driven in your manufacturing landscape because of the demands which your customers are creating? But it could also be things like, how do we create much more sustainable products? Sustainability is such an important topic with everything happening around us with climate change. So knowing the exact carbon footprint of anything that you produce is now becoming more and more important, not only for us as an organization in Siemens and other organizations, other technology companies as well, but any kind of manufacturer, whether this be in the food and beverage industry or in the automotive industry or in any other industry, everyone is looking at developing sustainable products. Lastly, I spoke a little bit about the traceable origin. So I was just speaking to my wife, and we were having a coffee, and she wanted to know where the ingredients come from and where is this coffee coming from and how is this being produced. And it's just a curiosity, because everyone in the new age now wants to know exactly how is my product produced, what is going in this, what am I putting in my body, right? So these are the requirements of our customer in order to drive, in order to answer to the trends actually, which is being driven by the consumer demand. So really, customers demand are driving the businesses, and manufacturers of today are looking at topics such as speed. So how do I basically deliver fast? Flexibility. We spoke about a little bit about that, because they want to create flexible manufacturing practices. Quality is always going to be an important topic, especially in the food and beverage industry. Everyone wants a quality product. And efficiency. Every time you actually set up any kind of manufacturing shop, efficiency is something which forms the liver. Whether you talk about any industrial revolution, you always want to gain certain efficiency. There are also requirements from manufacturers where they want to look at, how do I create a new business revenue stream by creating new business models? Is that a possibility with digitalization? So these are the demands our customers are driving as and asking us as technological companies to help them to solve that and secure that. Finally, the topic of security, because the more and more our customers use advanced products, advanced automation or software, things become more and more integrated and interconnected. The whole topic of cybersecurity comes into play. And actually, this will become one of the levers which will go along with digitalization, because you cannot do digitalization without cybersecurity. So the question really, which is in the minds of manufacturers now, is how do I answer my customer demands, and how do I embrace digital technologies in order to gain that speed, flexibility, quality new business revenue streams. How do I do that? What do I do about going there? First things which I want to mention is that you have to embrace change. Change is something which is inevitable. To survive as a disruptor, to basically thrive in this digital era, incumbents need to actually think of becoming a complete digital enterprise. And when I talk about becoming a digital enterprise, it's basically rethinking and actually analyzing every element of your business, be it manufacturing, be it supply chain, be the way you do business. And that's what digitalization will drive as well. So digitalization is a trend not only related to industry 4.0 and manufacturing, it's also a trend in the way you do business, right? So but this is something which is the first step into how do I actually go about taking digital technologies and utilizing that. When I talk a little bit now about the technology side of things, you have to look at both the worlds, the world of IT, which is more virtual, and the world of OT, operational technology, which is more the real world where people are on the shop floor trying to manufacture something, put things together. With digitalization, actually, what will happen is the merging of this IT and OT world, merging of the virtual world as well as the real world. The virtual world will be more used to realize and optimize. So you want to envision something, you want to create something. That is where you would use that virtual world technology. So there'll be a lot of software utilization in order to enable digitalization. But also in the real world, it's not only required now that we have a certain degree of automation in play. You actually want to use advanced automation which actually works with software, which allows you to work from anywhere, anytime. And that's what will drive the performance. So merging of this the vision approach, along with the performance is what is I call the integration of the IT and the OT world. Certain principles of Industry 4.0 will come into play, which is basically how do you horizontally integrate your complete end-to-end manufacturing, as well as how would you vertically integrate when you're also talking about things like IoT. So let me elaborate that concept a bit for your purpose and start really on how do you do this continuous optimization with the digital twin. The first digital twin is the digital twin of the product. So in this, you would use, for example, CAD/CAM softwares in order to envision your product, define it, and so on. But not only that, you would also want to simulate the performance of your products and so on. So you would like to see the flow and motion analysis, the engineering optimization, and so on. So this really helps into developing a product which you actually don't have to build physical prototypes. What happens under the digital twin of the product is that you're able to bring together that design principle, that mechatronics concepts or electromechanical design, and put that uh, essentially along with the simulation with a singular layer of digital data model behind it. And when you're able to do that, you're actually able to create that virtual product in a much more better manner. And that's what the digital twin of product is. Now that you have actually developed the product that you want to make, you actually want to envision how would you actually produce it. So which is where the second digital twin I would introduce to you is the digital twin of production. This is basically looking into how would you lay out a complete factory? What all do you need in your factory environment? How many people would you need? What kind of line setup would you need? Robotics and so on. What are the buffer times that you want to plan? And what's the output of your factory? All this can now be done in the virtual world. So without even laying a stone or a brick or in your factory environment, you're actually able to make your complete factory in the virtual world and make sure that this is working in a perfect manner to the KPIs that you want to plan it to. So normally the digital thread, as I call it, the interconnection between digitalization, this is where it would break, because you have the virtual product, you have the virtual product, great, people will go on and start doing manufacturing. Not anymore. you can actually integrate the virtual production with the real production already, and this is where the digital twin of production actually enhances with concepts such as virtual commissioning, which I will also be elaborating a bit further, where you can actually have an automation code already developed, test it in the virtual world, and just download it and play it to effect when you actually implement your automation in the real world. So Siemens has a huge portfolio on automation with motors, drives, controllers, and so on, and that actually enables the real world. But this is also advanced now in terms of software-based mechanisms, which allow us to do advanced automation. We could have stopped there and we could have said, yes, we already provide the automation which is required. But what we do actually is go forward in the real world to drive that digital twin of performance, which is our third digital twin. The real production really happens when your customer is actually saying, hey, I want this product. So it triggers probably in your ERP systems a requirement of a product which you need to produce. So the ERP system basically produces and gives you a blueprint, if I may say so, of the resources that you require, the work instructions that need to which you need to give to your workers, as well as the timing and so on for the final setup of your product to deliver to your customers. So in the past, I know when I started my career, we were still doing a lot of things on paper, and all this used to happen uh, from one floor to another floor. People would run around and plan in Excels and so on. But now, with the advent of technology and driving that even further, you can use advanced MES systems and manufacturing operation systems, which can help you really to plan and optimize your production models as well. And that's where you actually create a digital twin, which is enabled by a concrete manufacturing execution system, which help you to coordinate these different resources, whether these be people, materials, and other things, in order to actually create that product. The last part of the digital twin of performance is your product itself. So how is the product doing, and what are the requirements of the product, is something which you might want to track, and that is where IoT comes into play. But IoT is also important in order to trace how this product was produced and what was planned, whether it actually ends up doing that. So all of this is interconnected, and this is where the whole concept of also closed loop manufacturing comes into play. This to end-to-end value chain approach is what we call as digital enterprise. So anytime you want to do digitalization, you have to look at this end-to-end approach in order to plan your digital approaches. You can make step-by-step approach towards digitalization, but you have to have the vision of the complete picture, and then only you can make real transformation happen. Cybersecurity, network security will all be part of this as well, in order to ensure the security of your digital enterprise. So with this, Sam, your thoughts towards the digital twin, and if you would like to share some of your opinion about this.
Yeah, absolutely. Thank you, Shalabh, for that introduction. It's really great to be here, and thanks to Siemens for hosting the webinar today. So we've talked a lot about digital twin already, but I actually don't believe that we've given a definition of what digital twin actually is. There's a lot of organizations and companies out there like ISO and Siemens that have been offering up definitions of digital twin, and I do think that the Siemens PLM group covers some of the main points in theirs. Do we have the presentation back up, and we go to the next slide on it?
Yep.
Great. So yeah, you'll see this is from the Siemens PLM group. A digital twin is a virtual representation of a physical product or process used to understand and predict the physical counterpart's performance characteristics. Digital twins are used throughout the product lifecycle to simulate, predict, and optimize the product and production system before investing in the physical prototypes and assets. So again, good definition from the Siemens PLM group that I do think covers a lot of ground. And if we go to my next slide, with that in mind, one of the things that I find really interesting when we talk about digital twins is to think about how digital twins are not a concept that is owned by manufacturing and industrial companies. Virtual representations of physical products and processes actually has a lot of applications outside of just manufacturing, which we can look to for even more examples and inspiration and context. One of my favorite examples of this are the mapping and navigation apps that are on your smartphone and the story of how we got to where we are with them today. Some of you, I'm sure, remember that before we had these computers in our pockets, when faced with the question of how do I get from point A to point B, you would take out your map, which you would hope is up to date. You would plot out your route and you just go. Did you pick the optimal route? There's no way to really know. And if you hit traffic or construction or a road closure, you'd have to either take a guess or stop and take out your map and plot out a new plan. Then online mapping tools took off, right? Everybody remembers the MapQuest days. Here we're starting to go digital, and it gets to more useful tools like reliably up-to-date maps along with data like speed limits. And this starts to solve the optimal route problem by saying, I know that if you can drive along these roads at these speeds, then this is theoretically the optimal way to get to where you're going. But it's not real time yet. And that's where the smartphones start to bring us into this real vision and something a lot closer to what we think of with digital twin. Our smartphones provide real-time data back into the navigation system, and they close the loop by sending drivers back real-time feedback. Now we have millions of data points on all these phones, in all of these cards, giving us real-time information, just not on speed limits, but how fast they're actually going in certain areas and how that's performing right now. And with this data, we constantly update our optimal routes and reroute drivers as the digital system detects changes in the physical world. So this may be a surprise, but you do have a digital twin on an app on your phone in your pocket right now. And if your sense of direction is anything like mine, you probably use it all the time. So this same philosophy has fascinating implications for things like the medical field too. We're starting to explore digital twins of individual patients and showing how that can anticipate things like interactions between certain drugs or real-time updates to risk levels of treatments based on patient data. I mentioned all of this to try to take some of the science fiction out of the digital twin. Even if you're just making the move from a physical map to MapQuest before you get to a full-time real-time navigation system, there are huge benefits along the way, and we can see how that can affect us in manufacturing. From the real-time monitoring and predictive maintenance on production assets to simulating new processes and products, there's a lot to be gained from this convergence of the physical and the digital worlds for our manufacturers. Next slide. And the world is starting to take notice on this too. While the global digital twin market is around $3.1 billion today, it's expected to reach $48 billion by 2026. And unlike some of the other Industry 4.0 technologies, digital twin is expected to grow most in North America. Most of the manufacturing applications of digital twin today are in discrete manufacturing like aerospace and automotive, but we expect significant growth into process industries like food and beverage as they start to take advantage of some of the success stories and lessons learned in other industries. And finally, it's important to note that the foundations of digital twin are often in place and in use today, but they're often guided by people and may not connect to real-time data. A SCADA system is a form of a digital twin, but it usually requires a human operator to interpret the information and make decisions. We're going to see that start to change as we tie to more automated, intelligent computer systems into this real-time data feed to help us make more informed decisions and changes to our processes. So now that I've given you all a little bit more background on what the digital twin is and why it's important, I'd like to hand things back over to Shalabh to give us examples of the actual technologies used for product, production, and performance digital twins. Back to you.
Thank you, Sam, for that. And yeah, I'll try my best to give you a couple of examples on each of these digital twins. In no manner they are comprehensive enough, but then at least it gives you an idea of at least a couple of the portfolios which go under each of the digital twin. So let me start first with the digital twin of the product. And here really our portfolio is the Ops Center, Research and Development and Laboratory. And this portfolio, the main functionalities where this is used is around specification management and R&D data management. It helps you to, be flexible and transparent, so that you can capture all your experimental data in context of an R&D project. And actually, in that way you are lowering your cost, because you also have a singular system for all the process optimization, quality testing, and product recalls, and so that you have this in one place. That actually leads us to things like regulatory compliance, right? So real regulatory assessment of the product during the development stage is one of the key features of this portfolios. And it also helps in things like supplier collaboration, where efficient interaction with the suppliers on the product development can also be now possible. So it really, if you see, it enables closed loop quality from inbound to also outbound, right? When we talk also of the suppliers. The next, really, I take one example under the digital twin of the production, and here is our concept on what we call as virtual commissioning. I touched it a bit. It really helps us to validate a manufacturing process by giving fast and efficient engineering, so that the PLC code that you write once can be directly transferred from the virtual world to the physical devices. It helps with the automation code, which is already validated, and also in debugging the automation control logic and so on. So this, sorry, I think I went one slide early. So this really actually is basically the story around the virtual commissioning. And on one side, you basically use technomatics process simulation in order to simulate the project that you're trying to do by creating a model of the machine or the process. But on the other side is really what we call the digital twin of our controllers. In this case, the SIMATIC S7-1500, and we call it also PLC Sim Advanced. It has extensive function blocks, including communication, and supports multiple and distributed instances for simulation. By the way, we have another portfolio there which is part of this virtual commissioning concept, which is called SIMIT. And with that, you are actually able to emulate electrical and behavioral models such as sensors, temperature, pressures, hydraulics, and so on as well. So in all, what you really do is that you don't go through the trouble of actually physically commissioning something, and you have the opportunity now really to virtually commission the whole thing. And this really, if I may say so, given the way we have to work now in a remote environment, this really would drive a lot of efficiency improvements for our customers. Lastly, I touch a little bit towards the digital twin of performance, and here is our integrated operations with PC7, which is our DCS system, which helps in optimize production based on high plant and process transparency within a digital twin. It also gives us seamless transfer of data and testing of automation functions, right? When you use it in combination with SIMIT. The simulation functions of SIMIT gets the automation data directly from the PCS7 and COMOS solution, and offer the possibility to test the automation code and the process control functionality. By the way, with SIMIT, as I was sensing, this is a really good portfolio. You can also do things like operator training, so that your operators are trained before you actually end up doing the process. So in totality, the benefits is efficient and smooth system startup. You have increased safety and avoidance of errors and costly rework. So this really are the three digital twins, and I tried to give one example under each umbrella in order to see how they can add value to your operations. Sam, in just going further, would you have certain use cases of how these digital twin can be used and so on?
Yeah, absolutely. I would like to kind of take that and also kind of go through the product production and performance digital twins to talk about some use cases and examples and some tips on new philosophies for how we can approach the digital twin for these areas. So if we go to my next slide, we'll start with the digital twins for production, right? This is where we have a digital representation of our actual production process, and it's particularly useful when you're considering changes to production. For example, like the commissioning conversation that we were just having. Commissioning is expensive. You lose production from required downtime. You need to pay for an on-site engineering team, and significant changes are just inherently risky to your overall processes. So there are clearly some opportunities for savings by reducing time and reducing risk around commissioning activities. So when we talk about virtual commissioning, really the essence of what we're talking about is taking as many of, using the tools that we can to take any activities that would normally be done on site and trying to bring those back into the digital world using modern simulation and testing software to validate code and process changes. That's not to say that all of commissioning can always be done virtually. There are a lot of tasks that do typically still need some on-site presence, but the more we can bring off-site and test virtually, the less time and the less risk that we have in our actual commissioning processes, which just leads to direct project savings. If you can go to the next slide. When it comes to product digital twins, we're more focused on the digital replication of the physical product that we are producing. You can imagine how in some industries, especially those like automotive and aerospace, having a digital copy of every individual serialized part produced could really help with things like preventative maintenance on that part. But we are not serializing every cookie and biscuit that comes out of our food and beverage plants anytime soon. So that being said, there are still a lot of low-hanging fruits around for the food and beverage industry when it comes to product digital twins. Usually because that data often already exists and we just need to close the loop and integrate some systems to find the value. When your product teams have a new formulation or new packaging or even a new label design, these are not just being done on paper and put into a drawer, they're being done digitally. And that product team that makes these designs and decisions could benefit significantly from having access to real-world, real-time manufacturing data, from validating that new formulations are indeed being used and assessing their performance, to demonstrating how new packaging requirements may affect overall line throughput. All of this data could also be useful for supply chain teams that need to understand how new changes to product may change consumption and production rates. So what's interesting about these use cases is a common trend in Industry 4.0 projects in general, an expanded set of stakeholders. We need to start thinking beyond the four walls of the plant to maximize the benefits that we get from these types of projects. Maybe you don't hit the ROI that you are looking for with the digital twin project you had in mind. But if you open up that stakeholder conversation to include representation from supply chain, from research and development, and from marketing, you may find that they also have value in the data enablement initiatives that you are doing, and that by looking at the bigger picture, that is what justifies the digital twin for your business. And on the next slide, finally, let's talk a little bit about what I think is the most common digital twin use case in food and beverage today: performance digital twins. Remember, the digital twins are a fit-for-purpose digital representation of a physical asset, and we have those in our plants today for sure, from SCADA and MES systems to KPI dashboards in break rooms. These are digital communications to tell our people what is happening right now in the physical world. And we can start to see how, as we build on those digital twin foundations we already have, we can start to get more incremental value. And as we can get more data and connect to more systems, we get a more complete picture of what's happening in the physical world and open ourselves up to even more use cases. Usually the next step is to start to take the information systems we have today and start to close the loop to inform decisions. my OEE is below target. Well, why? And what could I do to bring those numbers back up? And how can I use that performance data to make corrections as soon as possible, or better yet, prevent those drops in the first place? So my main recommendation and takeaway here is to start small and iterate over time. Again, going back to that navigation example, we didn't make this sudden leap from having paper maps and manual route planning to all of a sudden having smartphones in our pockets with real-time traffic feedback. It took time and data and trial and error to get to where we are today, and the same is going to go for manufacturing, but a little bit faster because we have a good template to start with. You should be cataloging some of the digital assets that you have today. You should see if there are opportunities to close the loop with what you have, and you should plan out incremental improvement projects to continue to add value to these systems over time and towards a common goal. And as you're looking to incrementally move towards a more verbose and valuable digital twin, you'll quickly see that other Industry 4.0 technologies can enable you to do so. And one of the most important technologies you'll see for supporting the digital twin is IoT. Shalabh, since IoT is a significant enabler, I was wondering if you could talk a little bit more about IoT and how that will affect the food and beverage industry and support digital twins.
No, of course. Thank you very much, Sam. And I totally agree with you there, because IoT is something, and data is something, as I started my presentation with, which will drive future decision making. So every time you connect something and you start getting the information from it, it ideally should help you to make better decisions, right? And we know that the engineers in us all like a little bit of mathematics and data, and it helps us overall to make informed decisions. Even management, for that matter, whenever you want to report something to management, and there is some sort of breakdown or something would have happened, everyone would want to know why it has happened, where is the data for it, and what is the historical evidence for it, and so on, right? So IoT becomes really a big topic and a driver actually when we talk about digital transformation. So in that sense, Siemens really went ahead and actually developed its own IoT platform as well a couple of years back. And that was MindSphere for us. And when you look at IoT and connecting digital assets, we have the product portfolios, which would, of course, help from connecting not only automation of Siemens, but we also understand that other automation needs to be connected to a singular platform so that you can review the data, not only from a particular piece of machine, but maybe even along the process, right? And this could be for things like comparing and checking the quality of different production sites, because you want to benchmark, right? And that's where data comes into play, and you want to know why a certain error happened or a certain issue happened in one production site versus the other, if you are also kind of trying to standardize the way you want to produce, right? So that is where I think IoT will drive that forward, and a cloud operating IoT operating system, which in our case is MindSphere, will help you to drive that. Another example, and I think Sam, you also were referring to it, like OEE, especially in your filling and packaging lines, right? As an example, you want to ensure that there is constant availability. How is the performance of your machine or your particular operation, and what kind of quality is being driven? And again, you want to benchmark this versus other processes and other production sites that you may have. And actually, that's where the cloud-based IoT operating system actually helps, because this information, it's not that you were not collecting it before, but it was in segregated places. You didn't have enough computational power to process all the data. You didn't have applications to make this information simpler. So cloud-based applications actually help you to do that. Not only that, as I see where the IoT standards are really going, because you would also have, you would not only send information, everything into the cloud, because that would increase your cost as well, right? So you will have to manage between seeing what is the computational power right at the edge of your application. And this is where edge will come into play. So a lot of Siemens automation will have edge-enabled devices, and we're already releasing edge-enabled devices, which will have the computational power of what you are able to do in a cloud-based operating system. So you would have a mix of what you would do in these edge devices. By the way, they run the similar application, so you would log in via internet, and you are able to access the same information as what you would do in a cloud environment, right? So you still get that flexibility, that scalability which cloud provides, and that's where I think the future of IoT would go. One another example, and this is something also which we are also constantly innovating and driving new applications within our environment. And this is an example of a SIMATIC collaboration board, which is really to reduce the cost of maintenance and drive the increased availability of the line. So in order to see the quality processes are maintained, and really when you're trying to drive standardization across your global footprint, you want to make sure that that the causes or which have which have happened in order for the problem, that you're able to manage them in the same manner at different production sites. So it follows the Ishikawa principle there of cause and effect, and it drives that across machine, method, and environment and people. So you manage the task, you manage tasks and track the problem solving processes, and actually record that into a singular IoT platform, again within the MindSphere environment, in order to reduce your root cause identification time and also increase the availability of your line by sharing that global know-how, that global knowledge between all your employees. This will help you reduce paper. This will so you become more environmentally friendly as well, and you're hence able to use shop floor data which is every day available with your people or within your shop floor environment. You're able to record that and share that in a global, and that's the beauty of IoT. And this is where you would find that efficiency increase. But we could have been satisfied with that, right? And we could have said, yes, we have the digital twin of the product, production, and even performance, and we have the IoT platform. Everything is good, but where are we taking this further? Actually, what we are trying to drive is how do we solve this complexity? How do we make it much more efficient? And if we were only basing our decisions only on data, you could do a big science project out of it, right? Like some of the mathematicians and statisticians in the group might think like, okay, if I get all the data, I can, dig into this and create so many different variations of what could be done. But what we did is we started combining the physics-based model to the data-based model. So that's the beauty of Siemens, and the solutions are really integrated. So whatever you simulated in a plant environment and you made some assumptions in order to what you want to drive, you can actually, with a click of a button, drive the actual data back into the simulation, and you can see whether and you can see really now whether what you had planned, is it what is getting executed, because you now are backing it with real data. And that's where you start measuring the quality, the speed, what was my breakdown time, and so on, because you're combining what was planned to what is being executed today. And that is all combining and integrated with our solutions or around MindSphere, and as I said, around Technomatics. So this closed loop manufacturing is something which we are enabling, and we are making it simple so that the complexities which go around digitalization, you have simple methods in order and efficient methods in order to actually do and deliver it, right? Sam, that's it from really my side, really on the technological landscape. But if you could a little bit elaborate from your perspective, where do we go from here? How do you actually go about doing these solutions and implementing that in our manufacturing landscape? That would be great.
Yeah, absolutely. I would love to talk more about some recommended next steps, and as you said, where do we go from here to start to move towards this vision of the digital twin? So on my first slide, My first recommended step is actually around data enablement projects. So digital twins need good data to be successful. And that data can come from a variety of places like your manufacturing systems, ERPs, operators, warehouse management, and more. And some of these you might not always be used to connecting to automatically within your manufacturing environment. So as a systems integrator, a lot of my job is to go and investigate a lot of different plants and evaluate where their next steps should be. Given the maturity levels that I often see in food and beverage specifically, I do recommend taking a closer look at evaluating your MES for potential improvements, investigating in IIoT and edge devices, researching new data protocols, and having an assessment plan for some of your facilities. Now, to start with the MES layer, this is the layer that is going to be enabling communication from your real-time plant systems like SCADAs and your historian data with the business systems that are located outside of your plants like ERP, PLM, supply chain management, etc. Your digital twin could and probably should leverage data from both the plants and the business so that MES becomes a very important information broker in this overall platform. Now, as we just talked a little bit about IIoT and Edge, those are really going to enable you as well, especially when we're trying to connect to data in our facility that has been hard to get to before. If it was easy to connect, you probably already have it. Now we're more focused on the legacy equipment that might work very well for its designed control task, but maybe wasn't designed with data interoperability in mind. I definitely recommend, as you are looking at how you can bring those machines into your overall data network, take a closer look at the IIoT and edge device options available to you to figure out how to get to it. And as you do look into those devices, you're going to notice some of them support some newer communications protocols like OPC UA or MQTT. And this is a good thing. OPC UA is an Industry 4.0 standard and is significantly more secure than some of the earlier versions of OPC. And things like MQTT can drastically reduce the load on your network required to send and receive all of this new digital twin data. And of course, you can't fix what you don't know, so assessing the completeness, accuracy, and integrity of your data is a must. Learn where your gaps are and come up with plans on how to close those that are going to bring you the most significant returns. On my next slide, I'll talk about the opportunities around networking and cybersecurity. So digital twin projects, just by their very nature, mean that more sensitive company data is being sent and received across the entire enterprise. So your network may need to change to address the data security and data volume requirements from digital twin. Cybersecurity assessments and network assessments are clearly valuable tools to understand where your risks are and predict how your network will perform when supporting digital twin and other Industry 4.0 initiatives. It's also becoming more and more important to have a strategy for utilizing the cloud. While your first couple of initiatives may focus on getting the right data to the right people for continuous improvements, you'll often need the compute power of the cloud for some of the more advanced use cases like simulation or machine learning. Just like how digital twins are built for purpose, so are cloud enablement strategies. You need to work with your IT team and your stakeholders to determine how the cloud can bring value to your business and how that affects the manufacturing landscape. And finally, you can't collect data from and control what you can't talk to. So network infrastructure projects are often required to support your overall digital twin initiative. Again, I would recommend that you look into some of the suggestions from the previous slide around IIoT and Edge and new communication protocols to make sure that you're taking advantage of the latest and greatest developments in this space and finding the right solution for you. And on the next slide, my final recommendation around starting your digital twin journey is simply to understand where you're at today, envision where you want to go, and promote and document that vision in a comprehensive roadmap. A digital twin plan is not something you can get off the shelf. Just digital twin is too broad of a concept, and your roadmap really should be tailored for your company. So to help you construct that roadmap, you'll want to run some workshops to collaborate with that cross-functional team. And remember from earlier, that may be a little bit of a bigger cross-functional team than we're used to also. And collaboratively, this group will determine the value of digital twin for you. The output of those workshops is usually some type of roadmap document that details your vision for digital twin over the course of years, and should include some of the supporting infrastructure and data enablement initiatives that are going to be required to make that happen. That roadmap should also include a number of proof of concept projects that are designed to provide immediate value at low risk and validate that you've selected the right technology and use cases for your organization. And once those proofs of concept are complete, you improve on them over time, add more features to add more value, and eventually get to the point where you can roll these developments out to multiple lines and plants across the entire enterprise. So I know there were a couple of quick tips. I still hope that you found those starting points to be valuable. And I hope that you understand and agree that there's real value to digital twin. And this is a technology and philosophy that you can embrace today to get ahead, be more competitive, and to realize the value of Industry 4.0. And with all of that, Mark, I will hand things back to you to open it up to questions and close us out. Mark? Well, Mark, I can't hear you.
There we go. Thank you. Thanks, Sam and Shalabh. That was excellent, by the way. So very quickly, just to kind of build on what Sam said, what we're offering to help our food and beverage community as far as starting to build those first steps with the digitalization roadmap, we are offering a preliminary assessment. So this is our investment in you. So if you're serious about digitalization and trying to figure out where to start and how to put this roadmap together, our offer is that we're willing to do a preliminary assessment. The outcome of our preliminary assessment are going to be getting a good understanding of your current state, what your long-term goals are from an operations and a business perspective, and coming up with an agreed-upon vision and future state of where you want to go. And then we can start to figure out what the milestones would be and what that roadmap might look like, what the potential investment might look like, what the potential return on investment is. So if you're interested, drop us a line and we can start doing this preliminary assessment with you. We have a few questions. So this is our time in the last 7 or 8 minutes to answer any questions that you have. We have a chat window happening with a few questions in it already. So if you haven't already, please enter your questions down there and we will try and address them. A couple questions so far. One of them is, and I think everybody can see this, do you think the devices themselves will be edge devices? Are you seeing this? What type of devices are being used? Sam and Shalabh, do you guys have any thoughts on that topic?
Sorry, the question was, do we see the devices being themselves the edge devices?
Correct.
In automation? Yes, I think at first you would have standalone edge devices, but as we progress, we would have edge devices, edge already inbuilt in our automation portfolio, at least at Siemens. I think we are already in the process to release our first HMIs, which are edge enabled. So that would be something which we would also share. By the way, we have a automation and motion fair next month, in which we would share more details about our edge portfolio as well.
Yeah, I do agree with that. I don't think that when we're talking about the machines that are giving us the horsepower behind our digital twins, that we're not talking about the edge there, but there's certainly a great enablement technology, and there is value to having some intelligence at the edge that those real edge devices provide, right? So whether that be some data filtering or consolidation or something like that. So no, they're not going to be running the full simulations, but again, they can be a good way to help manage things like total traffic on your network. So again, with digital twins being very fit for purpose, They might only need data resolution at a 1 hour scale or a half-hour scale or something like that. But there could be other use cases around that edge device for something a little with a much higher resolution than that, right? So you can leverage the intelligence that's in these devices to make sure you're getting the appropriate amount of information at the right time to the right endpoints, one of which could be digital twin systems.
Very good. Thanks, guys. One other question we had was, how does simulation tie into the digital twin? So that's a good question.
Yeah, I could take an opening stab at that. So I know we did talk about a simulation a couple of times in here, you know, and we have different kind of customers and different layers of kind of data consumers, right? So digital twin is generally that digital representation of what happens in the physical world. So you have your physical world. The digital twin is kind of one of the customers of the systems that are feeding in that data. And simulation software can kind of be a customer of your digital twin. So you have your physical reality. That data is collected and represented in a digital model. And then the simulation isn't going to go out to the physical equipment again. It's going to leverage that model, right? So what you're doing is really you're kind of adding a layer of abstraction, adding in a layer of reusability to say, I'm going to run these simulations based on the modeling that is in my digital twin and kind of keep things in the virtual world. And then, of course, close the loop, the outputs that you get from that, suggestions that you get from that simulation, you implement in the physical world. You see the real data that comes back, which you use to update your digital twin, which you use to inform your simulation and do it all again, right? So that is the nature of this closed loop system that we're talking about.
Very good, Sam. Anything you wanted to add, Shalabh, or can I move on to the next one?
Yeah, you can move to the next. I don't think he left anything for me to say.
Yeah.
So that was
Very
very good. I mean, it was fully elaborated. As I said, digital twin is part and parcel of when I look into the overall concept. I think we have to look at from how do we really merge together the simulations with the IoT technologies, right? Which is what also Sam concluded in his way. And that's, I think, the future going forward when you would use simulation with a data management model.
Very good. So we have 2 minutes left. I have one question that I get, and I think it's worth our last 2 minutes, and that is, you know, how does digitalization or digital twin support continuous improvement teams in our processing plants? So most plants have a continuous improvement team. How could digitalization or digital twin help them with their objectives? Do you guys have any comments on that?
Sure, I'd be happy to take that.
Yeah.
So, yeah, I mean, I do think that a lot of it comes back to that idea of how we can be using this modeling software, and again, kind of simulating tests to see if a continuous improvement effort is going to be viable before we go into kind of a more lengthy and expensive design and commissioning process to try something out. It can really give you some cool new environments to experiment with on those continuous improvement projects before you go through and start implementing them on the floor. Anything you'd like to add? No?
Not from my side. Shalabh, are you good with that?
Yeah, good.
Yeah, no, that's good. That's good, Sam. So I think that concludes everything that we needed to cover. If there's any other questions, send them through. Our contact information is going to be up on the screen, and it's also going to be sent to everybody as a follow-up. So please let us know if you're interested in continuing the discussions. And if you'd like to do the preliminary assessment, we'd be happy to do that with you. Or you just want to have a discussion, we can do that as well. Or if you want to get us engaged in your digitalization projects, that's fantastic as well. Anything else from Sam and Shalabh that you'd like to add?
Yeah, only one comment from my side, which would be basically around the whole topic around digitalization has already started. There are already organizations which are already down this path. I think in Canada per se, I've seen that we can sometimes be very conservative about how we apply and utilize technology. So I would really encourage manufacturers to to engage with us in order to, whether they end up implementing it or not, that's secondary, but in order to engage with us on how the technological landscape is really affecting the way business is done and manufacturing is done really within the food and beverage industry. But not only that, we also look into various topics, and we could work through a piecemeal approach, and that's where the whole topic of that pre-assessment and workshop comes into play. So in order to define a complete roadmap on where a particular manufacturer needs to go, so it's not one size fits all. It's basically a custom approach which needs to be incorporated when you actually look forward for this transformation. That would be something which I would say as my final statements there.
Very good. All right, I think our time is up. So thanks, Shalabh and Sam, for all your effort and expertise. Thanks everybody for attending, and feel free to reach out to us if you want to have a deeper discussion.
Great, thank you everybody.